Yeah, so I'm Uri, and I used to work in Apollo and Meteor. I used to be part of the group that created the GraphQL spec. And then I quit that job because I wanted to create the guild. And I don't talk a lot about it. We're kind of like undercover. But we're kind of a group of a lot of open source developers that work together. You probably know all of separate individuals, but we actually work together. We do a lot of open source. So most of our open source currently today is around GraphQL and Apollo, or GraphQL in general. These are just like a number of open source things that we do, like Luna, GraphQL code generator, Apollo Angular from Camille, the other Camille, and GraphQL modules. But one of our philosophies is that each library here is under a person's name. It's not under the guild organizations or anything like that. It's kind of like our approach to open source. We think it's a more sustainable approach that lasts longer, and it works good for us. These are the groups. These are the people, and today I'm going to focus on, so we can talk a lot about different libraries that we build, and from each libraries that each of those persons are building, but today I'm going to focus on this guy and one library that he wrote. This guy is Camille. He works with us, and he is basically the creator and the main maintainer of Apollo Angular. But today, we're going to talk about Luna. And Luna is a state management library. And you're probably looking at me now like, go to hell. Like, we have enough of those. And that's probably what you're thinking, right? Like, oh, there's so many libraries for state management. Here's another one. It's going to just create another problem. So my goal for today will try to convince you that maybe we should rethink how we do today's state management and why. And maybe also why we started doing it the way we do it today. So maybe how many people of you are using NGRX? Okay, how many people using Akita? How many people are using ngXS? And how many people are not using any of those? What are you using? You don't in state management, great, because that works as well. So let's maybe think about why we actually use it and why we got to introduce to this paradigm. So it started probably with the new Angular, right? That everything became a component, which was kind of an idea was taken from the React community. And each component should be an individual unit that encapsulates itself. And that's fine. But then we need to also transfer data across those components. So the first thing that we thought of doing is just propagate through props all the data all the way to the top and then call the server to bring the data. And that's fine, but then if we want to change one component at the bottom, we need to change all the props all the way to the top. Now, if we have 10 components, that's fine. If we have 30,000, it's a problem. Then we probably thought about the Angular way or AngularJS way of doing things, which is let's put it in a service, right? Service will encapsulate all of the logic that we want to do in order to manage our data, and then the components will just get it from the service. But then there's another problem, because maybe there's a function on the service, and we change that. But there's other components that are using the same service, so we broke all the other components without knowing. And again, if we have 10 components, it's fine. If we have 30,000, it's much harder to now develop. So then another solution might be to just call from each component directly to the server. But then what's happening is that same components will call the same methods on the server. We'll get basically redundant data. And also, they might be rendered in different times. So now we might see one component that displays this data with a specific value, and another component that displays that data in another value. And that's a very common mistake when you start to grow into your applications. But then, we got Redux and NGRX and state management, and we said, let's just put everything, all the data in like one central shared immutable store. And now that data is shared, and it's shared across all components, and each component can just define their own selectors. And once we updated it there, everything is fine. And we created like very fancy and nice mechanisms to do that. Through effects and reducers before we put it into the state, and then when we put the state into the components, we use an observable, and all of those things. My main problem with this is that each box here, by the way, I just found out that I can like control this with my phone, so maybe, and that I can draw. Let's try something fancy. So, it kind of works. OK, so yeah, I don't know if it's the best. Anyway, never mind. So if you look at the reducer, for example, if we look at our own reducers now, what we're doing in the reducers is that we get the shape we get some response from the server. Now, the thing is that probably this response is not the perfect response that we would want to have. It's or a general REST response, or it's like this long nested list of fields, and it's not how we're going to render data to our UI. So now in the reducers, we write a lot of, thank God we have RxJS, so we're now operating and like iterating over the data once we understand that all the data counts, because when we send multiple requests and response to the server, we iterate over that in order to shape this like weird chunk of data into the data that we want to render into the component. So it's all code. So it's very nicely ordered, and it's great, and it's performant. But each of those boxes includes code. Code that basically what we do is shape our data or like reshape our data, which for me kind of, I don't know, it kills me a bit every time I see that kind of code. And if we look at Akita, for example, which is just another example of how you do it, again, like it's a different maybe mechanisms or different names, but at the end of the day, each of those boxes here are just, we manually organize the data before it goes into our store, and then we manually organize it when it goes to the component. And I found this quote very interesting. It's from a blog post from PayPal. They just moved to GraphQL, and they just released it. And what they say is like, and if we're looking at it honestly, when we take a closer look, we found that UI developers were spending less than a third of their time actually building UI. The rest of the time we spend like figuring out where and how to fetch data for multiple resources and what's actually going to come, filtering and mapping over that data, and orchestrating many API calls. Now, building UI is a nice to have or an afterthought. So I don't know if that's how you feel, but I'm just looking, for example, at the number of talks in this conference or any other conference. The number of talks that are focusing about us building UIs is maybe a third or maybe half compared to the number of talks that talks about how we do data. And that's kind of like correlated to the time that we actually spend doing that. Now, I don't know, I feel like we solved that problem once. Databases. With databases, they need a schema, and they need a query, and then all the data that we put into them is being normalized and organized for us, and then we can query it by any component or any client without affecting anyone else. That's what databases solve. And today, we just have this big blob of data that is not organized, and we just like throw it into our apps and try to manually do all that work. All the databases are doing, they basically ask us to just build a static schema. And then what they can do, they can take all this blob of data and just organize it. You have all your users in one table. You have all your messages in one table. Doesn't matter how it got to our client. So if we look at, like, for example, if hypothetically we would have a database on the client, we would get some kind of response. We will organize it in tables, and then we can query it, and there's no code involved. It's all static things exactly like that can look like exactly how we write our UI. So if we had this like smart store, super powerful store-like database, each component could just like declare the data that they want in the shape that they're going to render, and the data will come automatically. It is a guarantee. You don't need to iterate over anything. But then, you say, yeah, but SQL is hard, and I'm not going to write a schema anymore. So with Angular and NGRX, we already do that. We write TypeScript interfaces of our data. So we already create our schema. We just use it at development time. We don't do nothing with it in runtime. And also, like I said, SQL is hard. But GraphQL is like SQL for dummies. So with GraphQL, we can specify a schema. And if you can see, the schema here is basically TypeScript for dummies. It's like even, in my opinion, nicer or easier than TypeScript. And then we get a query language. And the query language just looks like a JSON object. And we can now take this JSON object and write it in the shape that looks exactly like our component and get exactly the data that we want. Now, all of you who heard about GraphQL are like, yeah, I know it's this thing that is against REST. But let's look at like a normal, regular like GraphQL scenario, which is over the network. That's what everyone thinks GraphQL is. So we have a server. We have this like GraphQL engine. And we write a schema. I don't know if you can see the schema. It's right over behind me. So we write a schema. You have a user and a message. Fine. Now, the client can just specify what data we want, like user and ID and the name. And this is the structure that we want to get. Now, this smart engine will go and behind the scenes for us, without the client even knowing, will just go fetch the data from wherever it comes and bring me one response with exactly the data that I want. Now, if I want to make it a bit more complicated, I want to have, for each user, I want all their messages, and for each message, I want the content. So again, this engine will go in, get like all the things in the background, orchestrate many multiple like API calls and all that stuff. At the end of the day, without the client even knowing it, the client will get the response that it wants exactly in the same shape as just one query. Like this engine was like a local database that you just query it and that's it, and you get the data. It doesn't matter, we can call even a third-party API or something. So that's great. That's what everyone thinks about GraphQL. If you haven't tried it or haven't like looked at it, go talk to me after the talk, and I will make sure you will. OK. But what if we take all these smart things, and as someone who worked on the spec, GraphQL is not related to REST or network. GraphQL is just a query language. We can put it over anything. It's like SQL. So what if this engine, instead of sitting outside of our client, will sit inside our client? This engine will now sit inside our app, and those boxes on that query stuff, those are not applications anymore. Those are components. So those are just individual components on the tree. And those individual components are querying data. They don't care about their parent. They don't care about other components. They just query what they need, and that's it. They will get the result exactly into how, like ready-made to be served as a observable in the shape that you want to render. That's it. So here we're querying like the local store, but also at the end of the day, when we call the server, it's just a regular HTTP or REST endpoint. Like even if your backend developers are like, we hate GraphQL or whatever, OK, use GraphQL on your local store. Or use GraphQL on your Angular app and get all those benefits. Or query Firebase and get the same thing, because Firebase is amazing. It's like the simplest thing, but then Firebase also gives you a collection, but the collection might be not in the shape that you want to render. Use GraphQL with Firebase, not a problem. Then you end up with like this smart store, but it's simple enough. It's probably simpler than TypeScript or simpler than SQL for sure. But you get all that powerful thing of like each component just holds their own thing. So for example, here is a component, and I'm rendering a title. So I just need to query a title. And if I want to change that component, I don't need to now go to a service or a reducer or whatever. I just need to add the field on my template, add the field on my query, and I'm done. And when you have 30,000 components, then that scales. When you do something else, or like one blob of data, that doesn't scale. So if I didn't convince you until now why the current state management libraries that we have are having a missing thing, then let's ask one last question. Why Facebook doesn't use Redux? Right? Like, Facebook introduced component-based architecture, and then they introduced the Flux architecture. And then Redux came to be as an implementation of the Flux architecture. And it's like the most popular thing, and we just followed. But why Facebook themselves is not using Redux if it's that good? Let's try to do like 1-minute research. So let's look at this library. This is like an open source library called Normalizer. Normalizes nested JSON according to a schema. OK, let's look at the motivation of this library. Many APIs, public or not, return JSON data that has deeply nested objects. Just what we said. We're getting data from our servers that are just not the data that we want. Using data in this kind of structure is very difficult for JavaScript applications, especially when using Flux and Redux. Oh, that's my girlfriend. OK. OK. So now you know like my boss. I worked really hard in my life not to have a boss, and she always looks. OK, so I'm looking at this thing. So this is the library Normalizer, a very famous library in the React community, normalizes nested JSON according to schema. I looked at the motivation here. And what I see is that this is for when we get results from the server that are not the way that we want to structure it. And they are deeply nested, and it's very difficult to operate them with things like Flux and Redux. Now, let's dive a bit deeper and go down and look at the credits. Who wrote this? Normalizer was originally created by Dan Abramov, the guy who wrote Redux, and inspired by a conversation with Ying Chang. Ying Chang is the key figure here. Ying Chang, she's a very inspiring developer from Facebook. She has, in my opinion, the two most important tech front-end architecture talks ever. She introduced the Flux architecture, and a few months later, she introduced GraphQL and Relay. Now, so those talks are must see. But what happened is between this time that the Flux architecture was introduced until the time Facebook got ready to open source GraphQL, Redux came to be. So this gap is just because Facebook open sourced GraphQL a bit later than they open sourced Flux. And there's many reasons for that, but we're not going to get into that. But that's the missing link. That's why everyone now, we just followed. We just said, OK, Redux is the shit in the Angular, in the React community. That's what we need to do. And I would just quote Ying Chang for that. Like, she introduced Relay, which is kind of like this smart store. And she said, Relay, React application framework that is the next evolution of Flux. So Redux was kind of like a step in the way. Relay or its equivalents are the actual things that Facebook uses when Facebook has like tens of thousands of components in order to do state management in a normal and scalable way. So we're just missing a piece in history. Now, it's already happening in the React community. More and more like thought leaders are like, OK, why a switch from Redux? And it's not that Redux is bad, like not at all. But there's just a missing link there. Now, you can use Normalizer, or you can just get a whole framework that will do all of that for you. So how am I with time? So if now I kind of convince you to rethink of that, then I want to introduce you again to Luna. Luna is a library which basically takes the best stuff from Relay and Apollo client, which is like the smart stuff from there that we saw that Facebook is using, and bringing in also the good stuff that we do have from NGRX, like the APIs and the middlewares and things like that. So, and it's basically, it's a single framework, complete solution for you to manage your data in your apps, whether it's a local state or remote state, because it's the same state. And we can organize all of that states, remote and local, in one organized smart database, smart store, and query it from each component. And it's a full framework, and it's like, you can have integration with all the other frameworks, so you know it's like, being used, and it's a good pattern across the industry. We don't need to invent something for specific framework. And as a framework, it comes with a lot of tools, like, you get with Redux, you get like the Redux dev tools and all of that, and with NGRX as well. Here you get the same tools, but even more powerful, because you can look, for example, at your normalized store. You can get the data, but then you can look at your data actually organized in kind of tables. And because it's like a full framework like Relay, it handles a lot of the stuff that you do when you call a network. Like when you want to call multiple endpoints and you wait for them to come back. When you, let's say, what happens if you want to send a request and the data is already in the cache. So you don't want, you just want to get the data from the cache and that's it. With NGRX, you need to write a bunch of code to do that, and that's fine, and you should. But here, it's just a flag. And it's a flag on each component. A component can decide if they want to just fetch it from the cache, fetch it from the cache and the remote, or just remote. Depends on the type of data. Also for server-side rendering, for example, like I can server-side render the app, hydrate the store, but then if there's a new query from a different component, but that query is a bit of different shape, but all the data is in the cache, I won't call the network again. It will happen automatically for me. With NGRX, I might or write a very, very complicated logic for that, or I would just end up hitting the network again, which is probably what everyone is doing. So I have an example. I don't know how much time I have, but what I want to show you is an app. Let's see that I'm not showing you my girlfriend again. Okay. Not that it's bad. So I created this app, and it's, so it's the same app. It's a WhatsApp clone. I created this just like it's fake data. It's not real, but it's just to demonstrate the app. It's like to have the basic, because it's the same basic app. So it's like I just created one big WhatsApp component that expects data, and we have a list of chats, and then a list of messages, and I can write it. I can write a message. There's a delay, and I can also like favorite a chat. And when I favorite a chat, this is just local data. This is not data that it's kind of like it's the same object of the chat, but this part of the data actually comes from local state and not from the remote. So I just wanted to demonstrate that. That when we look, currently what we do is we look at remote data and local data as like two separate things. But that's not the case. Like they're basically the same. It's like an enhancement. Many times the local data is an enhancement of the same object that we get from remote. So yeah, so we have a version. I don't have too much time to dig into that, but I will publish the code. So I have basically how NGRX is doing it and how Luna is doing it. I'll jump maybe very quickly about Luna, because you probably know NGRX already, and we don't have a lot of time. But I'll just demonstrate a few things. One, we want to load chats. With NGRX, we will have actions and reducers and all kinds of things like that, and we might want to shape the data before it comes to the store, or we want to now go over and iterate with RxJS on like running all the chats and like messing them around, and that's fine. But for me, it really kills me inside, because you can just right here create a query, and I'll just leave the those parts on the side for a second. And this is basically the shape that I want to render my app, the data that's going to be rendered. I just described that in a static way. And then when I go back here, I just get this query. Yeah, I basically get the RxJS observable with the shape that I want, and I render it. That's it. I don't need to iterate over anything. So it's great for performance, and it's great for rendering. Now, if some of you already know GraphQL, I didn't introduce anything new, but this is the new stuff. I can just put here, like basically the REST endpoints path and where to put it in the store, and I don't need GraphQL on the server at all. I can get all the power from GraphQL, but I'll get it now, even though my server is like, unfortunately, use REST. There's many more things. For example, here, the start field is a local feed. It comes from my client. But my component doesn't care. Like, if we would do it with NGRX, we would probably have like two separate observables, one from the local state and one from the remote state, and we will kind of like iterate and smoosh them together. Here, the component doesn't care. I just query data. I don't know, maybe it comes from the store, maybe it comes from remote, and that's it. That's scalable component structure. OK, so there's way more I wanted to show here, but I don't have time. But it's open source. Look it up. OK, so to summarize, save through like 2/3 of your time. Don't write those, like just add this one component of normalizing your cache. Maybe just use normalizer, maybe just use a complete solution. But every time, and this is the true scalable component architecture. This is how Facebook does components. And I'll tell you more of that. Like many of you are like, we have it already, we have NGRX, we don't want to change. Contact me. I will, for free, review your code and PR your code. I'm serious. I review your code and PR your code with an example. You don't need to merge it, just to show you that it's so much simpler, and it will save you time. Yeah, my time is up, so I'll just leave you with one thought. I just hope that now, when you go back to the code base and you write a RxJS observable, operator, that iterates over some data and smooshes it together and restructure it, you'll die a little bit inside, like I die a little bit inside. Thank you.
Sweet.
Right.
Need a new desktop background, too. So.
Yeah, I got to make sure he's working, so he's actually going to need a little bit of a desktop background. We thought we were pretty inspired by it.
Yeah, that's
and you can tell your girlfriend she had a cameo in your talk.
It's happened more often than you would imagine.
I love your idea because you start off with, oh God, another state management library, and then you.
That's what I thought, right?
That's what I thought too. And then you showed all the diagrams, and I'm like, why don't we just use databases? And that's exactly where you went with it. So you and me, we're the same.
And can we also talk about like these amazing diagrams too, like 3D animations going on? I'm like, wow.
The best I've seen.
And then some live drawing on stage. That's pretty good.
Yeah, that was just like before the talk. I was talking to Camille that there's no clicker, and then I found out you can do it with the phone. So I had to play with it a bit. But the drawings was actually for. So I always feel like people look at GraphQL as something like very complicated.
Yeah.
But once you visually look at it, it's pretty simple, and it's just well organized. And I gave this talk in ReactiveConf about how you do real time with GraphQL. And it sounds like a very complicated, like an expert thing and everything. But once you visualize that, it's like everyone understands it.
Well, I think you've also like described it in the best way possible. Is SQL for Dummies. That was perfect. Yeah. Now, if you ever need to write a book on it, there you go.
I can't believe you volunteered to give free PRs. I hate doing PRs. I mean, I don't hate doing PRs, but I hate doing PRs. And you volunteered to do that for free. I'm going to take you up on that.
Yeah, good. Good. I mean,
it won't even be related.
It's just I like every time I delete like those pieces of code that are manually iterating, I feel a bit better. I feel like I made the world a bit.
I mean, deleting code honestly feels so good.
Exactly.
It's so satisfying.
Yeah, there's tons of like tweets from people who like move from Redux to Apollo for their state management, and it's focusing on like the number of lines of code that have been deleted, and every tweet is like, I can't believe I deleted so much code. I can't believe I deleted so much code. So.
But what I really took away was we just need to be thoughtful about how we do state management, not so much let's follow the most popular libraries or what some famous person said. Like, let's think about our actual use cases and dive in and like just become better engineers in that way.
Yeah, exactly, like why, you know? Or when you go to pick a library, ask why. You know, there's in our community sometimes we just, we've been, told like this is how you do it. But ask why. It's not like maybe it's because of fear. Like people think that the people that write open source libraries are like super smart or super special, and they had this like amazing idea, and I don't understand it. That's not the case at all. Yeah. It's just people tried something, it somehow became popular. We see a lot of things that became popular and they're not the best. and this is open source. Open source is just random people putting stuff out there and see if it works. So if you don't understand why, it's not because you're dumb. It's because or the author didn't really explain it, or the author didn't really understood what you understood at this moment.
The author also is solving a problem for something they needed. It may not actually fit your problem.
Exactly, exactly. It's not like this divine knowledge that you don't have.
Yeah. Well, thank you so much for the amazing talk, and thanks for joining us on stage. Round of applause.
Yeah.
Thank you.